So let's explore some of the concepts around inheritance, and we'll follow that up with looking at a couple of code samples that illustrate how it works. So when we talk about inheritance in object-oriented languages, what we're basically saying is that we can define new classes based on existing classes. And when we do this, we have what's known as the superclass, which is the existing one or the parent, and the child class, which is the one that we're creating based on the existing one. And when we think about, if it's a good fit to extend one class from another, ask yourself, is this class a type of that superclass, or would it be a case where that superclass has a version of that object as part of its definition? So if we think about employees, so a type of employee, for instance, might be a janitor. So we could say, well, a janitor is an employee. However, we couldn't say that an employee has a janitor, or vice versa. But if we think about, say, something like a car and a vehicle, well, a car is a vehicle. Likewise, a car has an engine, or it has an engine. So we may create an engine object, but that engine object would not be derived from a car, for instance. Now, what inheritance allows us to do is actually inherit methods and data in the superclass. So anything that we may have set out in our superclass definition for, say, our vehicle, well, that would get passed on to the child subclass in this case, or the child class, which would, say, be the car. Now, child classes can create their own methods, but they can also do what's known as overriding existing methods. So basically, they take an existing method and create their own version of it. But one thing to look out for here is that it requires the same number and type of parameters to be passed to it as the method it overrides. Otherwise, this is what's known as overloading. Now, lastly, we can't override a method that's marked as final. So essentially, we've said in the superclass, nope, this is it. This is the only version of this method I want to exist in this hierarchy, so we can mark that as final. Now, we've got a few different types of inheritance. So simple inheritance, easy enough. A janitor extends from an employee superclass. So a janitor is a type of employee. We can also have multi-level inheritance. So we can have employee, which is pretty general. A janitor is a type of employee. So that's, again, kind of general. But then we might have a specific type of janitor. So a basement janitor in this case. So as we get further on down the chain, if you will, we're getting a bit more specific with the type of employee that we're creating. So again, employee, pretty general. Janitor, a bit more specific, and then more specific still, a basement janitor. Then we have what's known as hierarchical inheritance. This is where we have a setup that's, say, similar to a family tree. So we got the base class for employee or superclass. Well, from that we can extend janitor, okay, which is a type of employee. But now you think about an electrician. Well, an electrician is a type of employee, but it's not a type of janitor. So we extend that from the superclass in this case. And we could also add, plumbers, professors, whatever you can think of that would be an employee that's not a type of the other ones in the hierarchy, we could extend from the base class. So in this example, we have a base class or a superclass called attendee. So we're modeling an attendee to a conference. So we're pretty general with this one here. But we've got the name, the company, the phone number, whether or not they're vegetarian, the number of events that they're attending. We have a constructor, and then we have a method called attending events, and that just gives us back the number of events that they're attending. So now if we think about a delegate, okay, so a delegate is somebody that's coming to the conference versus, say, a presenter, which is, he or she is showing up and they're going to be presenting at the conference. So delegate extends attendee. So a delegate is a type of attendee. And we're adding an extra variable here, so a Boolean value for payment received. We're also including a constructor, which accepts the name, the company, the phone number, and whether or not they're vegetarian. we're using the keyword super to invoke the constructor that is in our attendee class, because delegate is a type of attendee. So anytime that we have a child class that has a constructor, we need to invoke the superclass constructor as well. And then we're setting our extra variable here, payment received equal to false. And then we're adding in method for simply booking the event. So again, we had a kind of general base class, if you will, for all attendees. Then we created something a bit more specific to represent delegates that are coming to our conference.